transparency, right? I mean, this is the key for the cloud providers, I feel at the moment, is just become more transparent about some of this data so that we can do the work to calculate, but just give us the data to do it, right?
Hello, and welcome to Environment Variables, brought to you by the Green Software Foundation. In each episode, we discuss the latest news and events surrounding green software. On our show, you can expect candid conversations with top experts in their field who have a passion for how to reduce the greenhouse gas emissions of software. I'm your host, Chris Adams. Hello, and welcome to another episode of Environment Variables, where we bring you the latest news and updates from the world of sustainable software development. I'm your host, Chris Adams. We don't shy away from diving into the details of sustainability in software development in this podcast. But if we want this to be a field that has widespread adoption, we need to make sure there's space for people entering the field from the wider digital sector, rather than being a specialist place that only really accepts people who have a PhD in green IT already. And it's also good to know about what's happening in the wider world too. So last year, we started a new format of this podcast that we call This Week in Green Software, which was a sort of roundup of stories and links related to, yes, you guessed it, green software, often with members of the Green Software Foundation coming in to share some of their stories that caught their eyes. It's a new year, and this is our first This Week in Green Software episode. And today, I'm joined by two members of cinq, one of the latest organizations to join the Green Software Foundation. So I'm joined by Brendan Kamp and Gabi Beyer of cinq. Hi, folks.
Hi, nice to be here.
Hi. Hello.
Cool. All right. So I'm not normally sure who to give the floor to first in introductions like this. So I'm just going to go for like alphabetical sort here, which I think places Brendan slightly ahead of Gabi in this one, right? So Brendan, are you okay just introducing yourself and what you do at cinq?
Yeah, first time I'm ahead of Gabi in anything, so I'm happy. So I'm Brendan. I'm a founding engineer at cinq. So I've mostly in my career worked with platforms and system level stuff. I did a small stint of developments on apps. And I've recently just started learning about green software. And so I've started a blog forum called thegreencoder.io to capture all the learnings and things that I've been doing.
Cool. All right. Thank you for that, Brendan. And Gabi, I think you're next in the sorting order. So yeah, over to you.
So I'm Gabi. I'm also an engineer at cinq. I've done a bunch of different types of engineering over my years, from Linux to platform to now doing green coding and optimization engineering. And recently Brendan and I both got accepted to do a talk at KubeCon. So we're excited for that.
Oh, wow. Congrats. I need to check, where is KubeCon taking place this year? Because I'm a little out of date when it comes to knowing where that massive conference moves around the world.
Yeah, it's in Paris.
In Paris? Oh, wow. That's not that far from Berlin. Maybe we'll see you in person in that case.
Oh, that'd be great.
Yeah, congratulations. All right. Okay, so thank you for that, Gabi. Brendan, during our intro call, just to get to know each other and figure out what we were going to talk about, you mentioned that you're joining this call from the Netherlands, but you haven't always lived in the Netherlands. And you even mentioned living on a farm at one point before. So before we dive into the world of like your life with servers, maybe we could talk a little bit about Brendan pre-cloud or some of that first before we dive into the nerdery.
Yeah, perfect. Well, so I've lived on a couple of farms. The first one in South Africa, I was born on a farm. And then a couple of years ago, I think it's about 6 years ago now, we moved to Germany, didn't enjoy Germany. So we decided to, mid-pandemic, do the only option of going into the middle of nowhere, Norway, and living just on the edge of a fjord in Norway for a couple of years. So yeah, and now jumping back to Amsterdam to get a bit more into the fray of things again.
So let me just get this. So South Africa, very, very warm. Germany
Yes.
Can be freaking cold, but also kind of warm. And you thought, nah, this is too warm and temperate for me. I'm going to go all the way to Norway, where you're like, this is maybe a bit too cold. And now you're back in the Netherlands, right?
Yes, 100%. Definitely a weather thing.
Well, I can sympathize with that as someone who's been living in Germany for the last 10 years and seeing a kind of recent cold snap, but also it getting chuffing hot over the summer, or comparatively speaking for Germany at least. All right. And Gabi, when we were chatting about this inside the CNCF Slack, which is the Cloud Native Computing Foundation Slack, I think, I saw your profile photo and I saw that you had a bike, but you also had an adorable dog on there. I guess there's a story there too before we dive into the world of servers.
Yes, that is Bruce. He is famous among all of my friends, and he's 13 now. I'm from Seattle, and he came with me to the Netherlands, and yeah, he is enjoying cycling around the city just as much as I am.
Oh, wow. So he's got a little dog passport and doggy visa and stuff like that, right?
Yeah, a full European passport.
Oh, wow. That's cool. All right. Thank you. And hello, Bruce, if you're listening, I suppose. All right. Okay, so thank you very much for giving us the time and introducing yourselves. Folks, if you haven't listened to this podcast before, my name is Chris. I am the executive director of the Green Web Foundation, which is a Dutch nonprofit focused on an entirely fossil-free internet. I also work as one of the chairs of the Green Software Foundation's policy working group, which basically does stuff related to new legislation, figuring out how to interact with new laws being made, and also creating some kind of fora for people who are basically trying to figure out how to deal with green software at kind of legislation level. We also do a bunch of other things at the Green Web Foundation, but I'll maybe mention those as we discuss. All right, then. So, Brendan, Gabi, I assume you're sitting comfortably, right?
Yeah.
Oh, yeah.
Ready.
Okay, cool. All right, just before we start, sorry, I almost forgot. While we talk about this, we will mention a few stories. We will link to all of these in a transcript and some show notes at the end of this podcast. But we also will have these as a markdown file on GitHub. So if there's a mistake for anyone who's listening to these, or there's something that you didn't quite understand, you can totally submit a pull request to improve it. And we will thank you in the next episode for your diligence in helping capture knowledge for future listeners. All right. Okay, then. I guess we can start with the news stories. Gabi, the first one, I think we spoke about this before. This is one that I might let you kind of talk about first, I suppose. This is Deep Green, which is the company based in the UK who put servers, I think, at the bottom of swimming pools or in swimming pools where they use the waste heat to heat the swimming pool, so you don't need to burn gas to heat the swimming pool. But that also has a nice effect of cooling the servers themselves. They've been doing a bit of work with a cloud provider called cinq, and I found out about this through, there's a serverless provider called Fermion who are doing some really interesting stuff with scale to zero servers. And I think a bunch of this stuff seems to be running on Kubernetes, which I imagine this, between the two of us, Gabi, you might have some exposure to. I've got to ask, first of all, have you used any kind of serverless tools in the first place like this? And do you think this is a trend that we're going to see more of? This idea of the cloud not just being in gigantic data centers, but in some cases at the bottom of swimming pools where the heat is actually being used in a productive way rather than being vented into the sky.
Yeah, I think that it's a great initiative. We actually, Brendan and I attended a talk a couple months ago about a Dutch company doing a very similar thing called Leaf.cloud. And they would put them also in pools. They've created, I think, a heater that would take the energy from servers and transform them into heat for pools and also apartment buildings. So they're putting them into apartment complexes to heat the housing.
I was always wondering, because Gabs kind of explained this a little bit when we were there, but I was always wondering how they do the security side of things, right? I mean, data centers are generally these walled off environments where you're storing companies' data. So understanding the technology underneath that to kind of like not allow those kinds of intrusions, I mean, that must be phenomenal, right?
So I think this is actually one thing where I'm moving out of my expertise, but I do know that this is actually something that is an ongoing challenge when you think about edge and stuff like that, because most of the time you like you say, people will talk about data centers as big buildings with big scary dogs and men often with like some kind of weaponry patrolling these. And this shift to a wider, more distributed set of places does mean that you might think about physical security differently to some of the other ones. Now, my understanding so far is that there is a bunch of different forms of encryption used, so that the actual contents is not particularly readable in many cases. But this is also something that, because we're on a podcast and there's more than just the three of us involved in this conversation, albeit many of them more passively at the moment, something we can find out a bit more about or even raise in future? Because you're right, Brendan, this is going to come up again and again and again. I'm also glad, Gabi, that you mentioned Leaf.cloud, because I'm actually quite a fan of them, because as I understand it, Leaf.cloud offer things like compute as a service, storage as a service, all the things that you might see from some of the big cloud providers. But so it's the same kind of API. Like the idea being that you don't need to care where the cloud is. You just need to know that your tests pass or you're getting the same things responding. Maybe you could just touch on that a little bit more, because I haven't actually used them myself, but I did read over their website, and they've got a cool domain. I think it's Leaf.cloud or something like that, which definitely got some nerd points.
Yeah, I actually haven't used it as well either, but talking with some of their engineers, I found them very interesting. Along with the domain, they have some funny lunchtime antics that they seem to get along in. But as for the technology itself, I can't really speak to it because I've never used it as well. But to kind of go off of the security question or thought Brendan had, I'm under the assumption that they might, for both use cases, since for my own one is serverless, I'm assuming that they don't store any data at these pool sites or at these hotel complexes. And it's they do still maybe have that big scary data center where they send all the data to, but yeah, the actual operations are occurring elsewhere.
I see. Okay. So maybe there's a thing where it's just being loaded into memory for a short period of time, and then it's being processed, and then the results are being put back into somewhere else in the cloud where it's somewhere more durable. Well, I guess there must be some people who seem to be okay with this, because Deep Green, in the last literally couple of weeks, there was a really interesting announcement. They raised £200 million for a massive raise to start rolling out these kinds of like integrated servers all around the UK. This was an investment by Octopus Energy, who are probably one of the kind of energy unicorns, I suppose, globally, basically. So that's something there. We'll share a link to that as well. So maybe we should ask one of them about, say, in your due diligence, how did you figure out how to answer this question? Because when we were looking at this, we thought this was cool, but we didn't quite figure out this part here. And that's probably the thing that we need to understand before we start diving into dropping servers at the bottom of swimming pools and getting them to execute cloud functions.
Yeah, just like off the top of my head, this sounds right in the realm of Kubernetes, right?
Mm-hmm.
Where you have this idea of you just have all these nodes everywhere, which would be the pools, right?
Mm-hmm.
Like these little servers are just nodes, and you're just using them as a pool of resources that maybe you can.
Very good there. Yeah.
Yeah.
A literal swimming pool of resources. Yeah. Okay.
Exactly, right. Which makes sense why they would partner with Xevo, I think, because I think Xevo's Kubernetes first provider.
I think that is the case as well. Yeah.
Yeah. So, I mean, it sounds plausible, and I can kind of do the mental gymnastics to how it could work, but it would be so fascinating to see some white papers from these companies coming out and saying, this is how your data is secure. This is why you don't need to worry, right?
Well, I'm glad you mentioned that, because we actually have a future episode with Kate Goldenring on Fermion, who basically was one of the first people to respond when I asked some really nerdy questions on the Green Software Foundation discussion board about how do people do isolation for this? Because one of the things about some of these serverless tools is figuring out, okay, how do you make sure that when you're running some code, you're not being affected by other people's noisy neighbors and stuff like that, basically. So yeah, we will definitely be diving into that, into almost excruciating detail in a future episode. So yeah, I'll be looking forward to that. Okay, thank you for that, Gabi. This is fun. Okay, next story that we had on this was this one in the Register, actually. So this was about users now keep cell phones for 40 plus months. And this is hurting the secondhand market, apparently. So this is one thing that, Brendan, I was thinking of you when this story came up, because we have seen a slowdown in people buying new electronics. And actually, this has been one of the real problems we've seen cited with embodied energy and embodied carbon in hardware. And now we've actually seen a new trend where people are not choosing to update their phones every year by the looks of things.
I absolutely love the headline, because it's like they're making it sound like such a negative thing. Oh, you're crashing this whole market of secondhand users, whereas you're just utilizing your resources for a longer time, right? And so, I mean, when I was going down the rabbit hole of embodied carbon, cell phones and laptops were one of the things that majority of the carbon emitted for these devices is in the manufacturing side of things and not actually in the electricity usage. So extending the lifespan of these devices just
It's
by,
one of the best things you can do. Yeah.
Yeah, exactly. But it's also going to hurt the companies that make the devices, right? And I think that's where there's the struggle is how do we still keep this growth going for these companies so that they can innovate, they can like do these things, but not destroy the world by littering it full of.
So these almost, yeah.
Exactly. Yeah.
So I just realized that we're talking about this and you've used this term embodied carbon that may be new to people. So when you say the word embodied carbon, I assume you're talking about the fact, I mean, you did a quite good job of explaining this, the idea that if you're going to have a phone, because loads of energy goes into making that phone, like you need to heat sand up to like 1200 degrees Celsius to make a silicon crystal before you can slice it and then turn it into a chip. That's going to be a bunch of energy used there. And that's usually come from fossil fuel sources. So that's the embodied carbon that you're referring to in that context, right?
Yeah, 100%. And it's also, they try and include the other things in terms of like transportation of the device from the manufacturing plant to the sales warehouses, the end of life carbon footprint, and all of these they try and calculate all together, and they have this global term of embodied carbon. And for these devices, and you might need to check my data, but I think phones and laptops are like 60 to 70% of their carbon emissions are wrapped up in the embodied carbons. Whereas servers, funnily enough, because of the immense power or energy that they use, it's only like 15 to 30% their
Okay, so
emissions.
it's the other way around then. All right.
Yeah. So servers, the embodied carbon isn't as big, but it's still a nice slice. And funnily enough, this is something that Gabi's and I have been struggling is how to calculate embodied carbon for like using of devices, right? If you only use a device for a small amount of time, like how much of that embodied carbon pie is
attributed to you, is your share versus someone else's share, right?
Yeah,
you do need to kind of, I mean, maybe this is actually one thing that we'll just touch on a little bit before, because Brendan, what you mentioned just like, the framing of the story, like, damn it, these people should be consuming faster, right? I think that's an interesting one because there's also one interesting development we've seen on the policy side is that Google, which the register always refers to as the chocolate factory, which always makes me giggle. They're one of the second firms now that has actually come around on right to repair. So I think last year or the year before, you had a whole bunch of actual shareholder activism. You had some people putting forward a kind of shareholder resolution to basically start looking into the ways to reduce the embodied carbon of owning a Microsoft Surface. And eventually it passed, despite there being a bit of pushback against management saying, no, we don't want to do this. And now you saw Apple come around last year saying, oh, we're kind of okay around this right to repair. But they had this whole notion of like parts pairing, which basically meant that it's right to repair as long as you only ever buy the parts from one provider at Apple's prices, which is probably good for Apple shareholders, but that does kind of mean that is not possibly the intention of this. And then Google have recently come through and said, yeah, we're actually coming around on this as well because we realize we've got loads of Chromebooks around. And if we can fix them rather than replace them, that might actually do something for the embedded carbon. And also this whole parts pairing thing, which has been one of the last things that large tech firms want to hold on to. They've said, yeah, we're okay with not having the parts pairing thing as well, as I understand it. So this is actually an interesting development. I don't know if there's another loophole or something like that, but this really caught my eye and I figured I was thinking of you when I read this actually, Brendan.
But now also coming out with the new EU greenwashing laws that have recently been passed. For Google, I would assume this would start looking good for their data because very soon these big corporate companies, if they want to do work in the EU, are going to have to start providing this kind of data of just how much emissions are their devices emitting, etc. And if they are reusing. And I mean, I've always felt like this idea of you can only use our things is ridiculous because, for instance, if your sole goal is to make money, it works. But now we're shifting to a world where there's other incentives. And if those incentives are, hey, we want to reduce our carbon, then if a vendor is providing the hardware, those emissions are for the vendor. They're not for me. They don't go towards my numbers. And this means that you have a more collaborative society. So yeah, I'm really interested to see where this goes, especially in the next couple of years. Fit for 55, the new greenwashing laws, because I think these tech companies are going to really have to do some changes.
All right, you've added a couple of things, and Gabi, I'm going to ask you a little bit about. So there's a couple of interesting terms that you mentioned there. So fit for 55. This is one of the big announcements inside Europe to basically say we're going to reduce emissions by 55% by 2030. And there's a bunch of new laws and things tied to that. And you also spoke about this anti-greenwashing resolution. We'll share a link to that because I believe that was passed last week or the week before inside European Parliament. So there's a few follow-on steps, and essentially saying things are carbon neutral isn't going to fly unless you have a really, really clear way of backing it up. So when Apple have mentioned things like they're having an entirely carbon neutral watch, in Europe, that won't be a thing that you can do. And I imagine we might see this also percolate into other territories as well. All right, then. So, Gabi, there's a really interesting story here, which is this is actually UBS, the bank, who are basically saying, hi, we're trying to develop a baseline for some of our early steps. They talk a little bit about how this is quite hard. And as I understand it, you spent a bit of time and you even wrote about your experiences taking some steps to try and measure things just on a single laptop. Maybe we could talk about that before we speak more widely about this one here, because there's some really nice things to touch on for the UBS story, and they explain a few steps they've taken. But maybe we just touch on your experiences with your first steps and then go work a bit more widely, because I think you did write about this after, was it the SDIA Green Coding Workshop in Berlin? But I think you mentioned something like that. Maybe you talk a little bit about that, then we can go into the wider case here, because it's very rare to see large organizations talking about this. And to get there, you need to figure out what to do on your own laptop first, right?
Yeah. Inspired by the SDIA. Yeah, I wanted to measure the carbon emissions and the energy consumption of different processes running on my laptop. And that was challenging enough in itself. And to do that, I used this Intel RAPL hardware component that can measure and I used perf, which is also a Linux command line tool which utilizes RAPL, which then can get the amount of joules of energy a process is running. And then once you can get that energy consumption, you must calculate it into kilowatt hours and again, multiply by the grid database, and you can get the carbon emissions. So there's a lot of steps just to get the energy consumption and carbon emission data for a single laptop. And to build off of that, we've been working a bit on figuring out how to measure different cloud services, their emissions, specifically like VMs, which is similar to what UBS seemed to do because they were running VMs for their application data. And that is another level of challenge because the hardware components are being shared within the services. So you have to kind of then determine how resources are being shared.
Yeah, so it's not just a single laptop. It's like you're sharing your laptop. So if I understand it, so doing it's hard enough with a laptop when it's just you owning the laptop, when you don't have to share that laptop with other people. When you're looking at a server, the number of people who you're sharing it with could be changing over time. And that means that there's almost like a kind of mathematical integration problem that you also need to wrestle with as well. And that's another thing that makes it somewhat more complicated.
Or maybe just to touch on, also, you did the CPU calculations for VMs, but what you're currently struggling with is memory, right? Because there's no data on memory.
Yeah, that's specific to the cloud, though. We don't have their like hardware memory information, like what kind of DDRs and RAM stuff they're utilizing, and each one kind of emits different energy usage depending on that. So it's kind of difficult to say like this application's using this part of memory, whereas this application's only using this much. So that's been hard to calculate.
It's a real challenge. Yeah, this is something that we've come across quite a few times. There is actually two things that may be worth touching on here, actually. So inside the policy working group where we work, we've seen various sectors really struggling with trying to come up with some reliable numbers for this. And there's actually a roundtable that we're organizing in the coming months, specifically for the financial sector, because amongst all of the sectors so far, they're weirdly one of the more transparent so far. I think it's partly because they've bought so many servers already, because they actually have access to these numbers, whereas some cloud providers don't have this. And we'll share a link to a post about, there's a bank called ABN AMRO. They're the third largest bank in the Netherlands. They actually were on the record basically saying, look, we've looked at our figures and 40% of our emissions are attributable to our own infrastructure. And partly this because they own some of their own servers and they're moving to the cloud. But this is one place where it actually has been easier for people to come up with these numbers. But when you get to the cloud, it becomes, as you mentioned, it's way more complicated. Because Gabi, you said, who's RAM? What CPUs? What machine? The fact that you don't know where it is means it's really, really hard to model some of this stuff as well, actually. And yeah, I think this is going to be an ongoing challenge. But I wanted to ask you, actually, when you're on this, there's a project that I think I saw in the kind of recent GitHub repo called, is it called Carbon Cloud? This is a Golang thing or something running on the server. Maybe one of you could talk a little bit about that, because that caught my eye, basically.
It's all Gabi.
Yeah. Okay. So Gabi, I'm curious, maybe you could talk a little bit about some of that, because it seems like you've tried to wrestle with some of these problems yourself firsthand.
Yeah, written in Go, we're trying to measure the carbon intensity of cloud software. But our goal is mostly to do it in real time and to be able to provide like a metric that users and developers can utilize and get that quick feedback cycle loop to see what is changing and going on in their code base that could be producing these higher emissions or change in emissions and stuff like that.
All right, cool. Well, in that case, one thing you may be interested in is, so in the GSF, there's a project called the Real-Time Cloud Project, which I've been involved with, and we'll talk about a little bit later, because this is one thing that, as someone who's working in an organization that cares about fossil-free internet, a significant chunk of that is going to be, well, decarbonizing the power. And this is one thing that we've struggled with as well. It's really, really hard to find the numbers for this kind of stuff. And that probably brings us to the story that I kind of put forward here. So there is a really interesting story from Data Center Dynamics about Amazon basically saying, they're claiming they're the world's largest buyer of renewable energy in 2023. They said this story, and we'll share a link to this. And this sounds really, really good when you first think about it, right? Like, they're a large provider. They basically mentioned that they've invested in something like more than 100 new solar and wind energy projects and stuff like that. This adds to a total of nearly more than 500 wind and solar projects globally, right? So these are the figures that we have here. And this sounds, on the face of it, kind of large if you were to assume how big Amazon is compared to other providers, right? And I've been really struggling to figure these figures out, because if you look into sustainability reports from any of the large providers, Amazon as one organization that hasn't really published its absolute energy use figures ever, or it's very, very hard to find this information. If you sign an NDA, you might get big figures yourself, but most of us don't sign NDAs with Amazon because, well, I'm not spending 15,000 euros at least each month with them myself. But what we found out when I was doing some research into this was the Carbon Disclosure Project is one place where these figures are submitted. So I did a bit of research myself, and we've shared a link to this specifically. Google and Microsoft both published their CDP responses, listing a bunch of really interesting answers to the questions. And this is helpful because it allows us to have comparisons across each of these. And the short version of this is that when I looked into this, the figures for absolute energy use were about just under 40 terawatt hours, 39 terawatt hours is what was listed inside this, which is, for most of us, we don't know what that figure would even kind of compare to, right? Like, is it like, it's like, you know, gigawatts, gigawatts, or kagoulis, like, what does that even mean? For context, Ireland, the entire country, used 34 terawatt hours of power in the same year as this reporting. So Amazon is using more power than Ireland, but they also, in the Carbon Disclosure Project, they also list how much renewable energy they've used and therefore have purchased. And they've purchased 35 terawatt hours of clean energy. So they've bought more clean energy on an annual basis than Ireland, the country, has used in the same year, which is just mind-blowing as a figure. And it kind of gives you an idea of the scale we're talking about here, for example. Brendan, you got something to come in there?
Yeah. So I just have a question, and I'd love to hear your opinion on this around carbon contracts, right? Mm-hmm. So my understanding of carbon contracts is you're buying energy that would be used by another company, or green energy, and you're then saying, all right, that is now my green energy. So it's not necessarily a reduction technique, it's more of a auditing technique in my mindset.
I see why you would say that. And to be honest, the market structure is such that it's actually quite complicated and not very accessible for most of us. All right. I think what you may be referring to are two separate things. So if you want to report electricity usage and the carbon from electricity usage, there is a approach which is based on your usage tied to your location, right? And there's another approach which is designed to recognize the fact that you've bought a bunch of renewable energy. So one is called the market-based approach, and one is called the location-based approach for this. And one of the challenges that we've had over the last 10 years is that you can basically buy power, and separately from your use of that power, you can just buy some certificates that have been sold by a bunch of green energy producers, because it may be that in certain parts of the world, people don't value those certificates. And then you can then apply that to your usage to then say, well, this is quote unquote green power. Right? This has been the approach that has been used. And Ireland is a particularly interesting case because in Ireland, you've had the Advertising Standards Authority basically say, yes, this may be how your market works, but it's still misleading to consumers. So therefore, we will not accept, we're going to stop Irish energy providers selling green energy that uses this certificates-based approach. Now, the thing that's quite interesting with Amazon is that there's a project inside the Green Software Foundation called the Real-Time Cloud Project, which, Gabi, I mentioned before. We've actually got someone who's been literally counting up all of the output from every single project to compare this to what the figures might actually be, so that you can get some idea of what the physical production might be versus the amount of credits that might need to be purchased. And we can also link to another podcast where we talk about this in terms of additional, deliverable and timely as ways of talking about green energy, where if you're going to make a claim around green energy, you need to be able to basically address these things. We'll link to the podcast episode which dives into this in more detail, but the short version is, if something's additional, like you said, it's not reallocating green energy, it's introducing new energy into the grid. And this is one thing that some of the large providers tend to do now. They make a big story about, hey, look at this new wind farm that we've helped create. And that is usually financed through a power purchase agreement, the way people do that. So that's kind of the additional part. Now, deliverable is another thing. So deliverable in this context might be, I financed a renewable energy project in Norway, but my use is in Spain, right? Which is the other end of Europe. Now, it's not very plausible that the power would go all the way across Europe without any losses to then power your data center in Spain, for example. So that's deliverable. And then timely is basically saying, well, I funded a bunch of solar panels, so therefore I'm allowed to say my servers running at night are green. Now, again, that is not necessarily the most plausible claim that you would make. So this is why you need a combination of all these three. And this is one thing that I believe Nina from Energy Tag in the episode we'll link to explains in a lot more detail. But anyway, going back to the original story, yes, it's really, really good that you see a company like this saying, yes, we're the largest provider, but they're just one of the largest users of energy, full stop. So just by dint of the size, that they're going to be one of the largest. And when you look at the amount of energy used versus their revenue, I mean, I've shared this research, we can see if you assume a figure of 100 euros per megawatt hour or $100 per megawatt hour used, which is a pretty generous figure for data centers. It's what, 0.7% of Amazon's revenue. And it's less than 1% for Google's revenue, less than 1% for Microsoft's revenue. So this is actually a good thing, but this is often a more statement of how large these companies are, rather than how much of their money and their revenue they're dedicating to basically green energy. And that also tells us that we could probably be moving way faster. So that's as a executive director of a nonprofit talking about this, saying we should probably be doing this more, especially when you look at how much money has gone to basically buying your own shares to make your share price go up, rather than make sure that we have a functioning society and habitable Earth.
So do you foresee any of the new regulations coming in increasing the percentage of revenue that they'll be spending on renewables?
This is an interesting question, because typically, when you look at it historically, you've seen that a significant part of the funding for renewable energy has come from various kinds of subsidies to make it easier for companies to get on board. Like, companies will basically say, I'm not going to do this until it makes sense for me on a financial basis. And if you're a hyperscale provider, or if you're just a large user of energy in total, the reason you would have a PPA is, or you would use renewable energy is, yes, it makes you look awesome and look like you care, and it's good, but it's also the cheapest way to buy power, right? So it's almost willful to choose to buy fossil-based power in lots of places if you can get a contract like this. However, there are complications about making sure that the power is both timely, deliverable, and additional, like we've mentioned. But these numbers, the figure of $100 per megawatt hour, this was something that I ran by some of the energy modelers who we interviewed before, and they said, this figure is, that's not an unreasonable figure to use. You could do that. So if each of these companies doubled the amount they're dedicating, they could absolutely all go to 24/7 fossil-free very, very quickly. And there are smaller companies that are already doing this, who are already at 99%. So we'll add some links to that. But I better move on to the next story because this is something that I could talk about literally for hours. All right, then. So the next story, this was one I think that you shared, actually. Tripling the lifespan of servers. Why we retrofitted 14,000 servers. This is a story from Scaleway, the European cloud provider.
Yeah.
And Brendan, is it okay if I just hand over to you for this to explain this one? Because you shared this, and I think it's actually quite interesting to see a company talk about this.
Well, this was just something that, pops up on your feed and caught my attention. Obviously, with talking about embodied carbon quite a lot recently, the lifespan of servers is very much at the forefront. And Gabs, correct me if I'm wrong, what are we estimating the lifespan of servers? Is it 6 years?
I think it's 4, maybe by
4
Dell.
years. Yeah. So like a 4-year server. And what Scaleway has done is they actually went into their data center and did some, a bit of analysis on what parts of servers were failing. And it turned out in this case that majority of them were hardware components, the RAID controllers. And in the RAID controllers, the part that was failing was a battery. Now, RAID controllers are slightly more old school components of servers. Nowadays, you have software-based RAID. And so what they did was they thought, okay, we can actually remove this component and potentially that could prolong the life of these servers and just switch them over to a software-based RAID. Now, don't ask me what RAID is. I'll probably get it completely wrong, but
it's a redundant array of something drives is what it is.
It's a hardware thing. But just the understanding that they invested all the time and money to go and do, I think they did 24 or 25 POCs, just proving that this could work. Then they went in and took out 14,000 of their servers, moved them to a new data center, updated them with these new controllers, and put them in and carried on running them. And they had no reduction of quality in service, right? So the servers performed as well, if not better, once they'd done this. The hyperscalers also starting to invest in these ideologies a bit. I mean, the amount of servers we can save, the amount of embodied emissions we could reduce by, it would impact server companies quite considerably. But I mean, something has to give at the end of the day. And another thing that they also did mention, which I found fascinating, was because we currently have this big chip shortage due to,
supply chain,
etc. The servers that were redundant, that they couldn't migrate to this new setup, they stripped for parts and they're using those parts to maintain the servers that they updated. So they've kind of really tried to look into every single facet of these servers and kind of see how much longer that they can make them last. And I mean, from 4, as Gab said, to 10 years now. I mean, that greatly reduces the percentage of the embodied carbon of those servers, right?
Yeah, that is. And that kind of scale, that's a meaningful thing to look for.
Yeah.
I guess we should probably be asking for these figures when we purchase cloud services. Ask, can you tell us about your embodied carbon for your service as well in that case?
Yeah. Transparency, right? I mean, this is the key for the cloud providers, I feel at the moment, is just become more transparent about some of this data so that we can do the work to calculate, but just give us the data to do it, right?
Gabi, I see you nodding along like this is a thing that you might have some scar tissue developed over the last couple of months trying to wrestle with.
Just a little bit of blood, sweat, and tears.
Yeah.
Nothing can't handle.
Okay. So you heard it here first. Please share these numbers if you operate some kind of cloud service or you're providing the infrastructure that people run on. Maybe it's worth asking the Leaf.cloud folks. from up there, because they might have some of these numbers. All right, then.
That's a good idea.
Oh, good, folks. Yeah. I've really enjoyed chatting with you, and I've realised that we've almost hit the hour that we have allocated, and I haven't got around to rounding this up and basically plugging this big event that's coming up. So on the subject specifically of transparency, the Green Software Foundation runs a kind of annual hack day or hack event, basically. Rather than trying to compress building anything into 24 hours of Red Bull, chocolate, and delusion, it's actually spread over a longer period of time. So this is actually a hackathon kind of thing. It starts on the 18th of March and runs until the 8th of April. So that means that as people who might be involved, we do get to sleep and eat and see our families and like live full lives as people rather than just machines that crank out code. And this year, the focus is around a new initiative called the Impact Framework, which is essentially a bit like a kind of manifest file, or like you can think of like a Terraform state thing for your entire system that enumerates through all of the figures for like carbon emissions or something like that. It's designed to be kind of open and flexible. And there's a hackathon all about that at hack.greensoftware.foundation. And there's some specific awards around talking about measuring things beyond carbon. So that might be useful for some of the things we touched on today, creating the best model so that if someone wants to figure out the emissions of using a service, like say the carbon cloud thing, that might be an example. The best content for explaining why this matters. There's the best contribution to the framework itself because it's an open source framework written mostly in TypeScript. And finally, because there's loads of undergraduates who will be alive longer than we will be and have to wrestle with this, the best undergraduate project as well. So people can register interest there. And I think that's me done with my contractual obligations for this podcast, I suppose. I really enjoyed chatting with you. This has been loads of fun. Thank you so much for coming on for the day.
Thanks, Chris. Yeah,
really nice.
It was great. Thank you.
Thank you for having us. Yeah.
Before we go, I just want to check if people were interested in the work that you do or wanted to follow up. Where would I direct people's attention? Is there a place, a LinkedIn or a blog that you'd like to talk about? If I ask Brendan once again first, because it's alphabetical, and then I'll ask you, Gabi, if there's anything you would point people to, then I think we'll just wrap up after that, actually.
Yeah, I mean, my LinkedIn's quite active. I'm terrible at Twitter. So it's just Brendan-Kamp-757, I think, is the end. And also, we do write quite a lot of blogs. So I've got blogs.thegreencoder.io and also blogs.re-cinq.com, where you'll find a lot of our blogs and things. And Gabs, code-wise?
Yeah, probably LinkedIn as well. Maybe, yeah, you can look at our GitHub also on Resync and Cloud Carbon, and yeah.
Go from there. All right, then.
Great.
Well, thank you so much for that, you two. As we mentioned, I'll put a markdown version of the transcript and the show links that we have. And if anyone wants to be mentioned with a PR for anything we fix or a typo, then here's your chance for tiny 2 seconds of fame in the next episode. All right. Thanks, folks, and have a lovely day. All right. Ta-ra.
Perfect. Ciao.
Bye.
Hey, everyone. Thanks for listening. Just a reminder to follow Environment Variables on Apple Podcasts, Spotify, Google Podcasts, or wherever you get your podcasts. And please do leave a rating and review if you like what we're doing. It helps other people discover the show. And of course, we'd love to have more listeners. To find out more about the Green Software Foundation, please visit greensoftware.foundation. That's greensoftware.foundation in any browser. Thanks again, and see you in the next episode.